remember the coffee bean trail, Catherine?
How can I forget? You
I know.
spilled it all over me.
So we talked about how there would be 3 big parts to lesson 1. And we spoke about image and text view, and then we learned how to style those views.
Yes.
Where are we going next?
Well, I was thinking, since we only have one view on the screen
Yeah.
right now, it's a little boring, so we should add more than one view.
Right. And if you think about it, all of the fun apps that we use, YouTube, OkCupid, what's another one that comes to mind?
Gmail.
They all seem to have more than one views packed in very neatly on the screen together.
And the way they do that is through ViewGroups. So we'll learn about that next. And that gives us the power to also position views on the screen where we want them.
Right. So let's talk about ViewGroups next.
So far, we've only had a single text view or a single image view on the screen. If we want to add another view below it, we could try to just copy this and paste it below it. But then we get an error. It says the XML document has more than one root view. There can only be one root view, and it should enclose all of your other views. If we want both of these text views to appear on screen and not be lonely anymore, then we need to put them in a view group. The view group will then be the single root view for the layout. View groups are also views, and they are rectangles on the screen. For example, the red and orange rectangles here are all view groups. They can have a width, a height, or a background color, or other attributes. The background color here is orange, but it could also be transparent, so the view group isn't even visible to the user. Instead of holding some content like text for a text view or image for an image view, the content that a view group holds is other views. You can think of a view group as being a container for views. When a view contains other views, we call it the parent of these views. So this is the parent, this is the parent, and this is the parent. When a view is inside of a view group, we call it the child of that view group. So this is a child, and this is a child, and this is a child. Same here, there are 2 children here and 2 children here. Continuing with the family language, if there are multiple children, then each of those children are siblings to each other. So these are sibling views and these are sibling views. Okay, that was a lot. To help you remember all the terminology around parent and child and view group, I want you to meet a very nice family called the views. You've already met Tommy TextView. He's pretty great at displaying text. You also know his sister, Ivy ImageView, who displays very beautiful images. And now we're meeting their parents. It's always nerve-wracking to meet the parents. So we have Laura, the LinearLayout, and Ray, the RelativeLayout. These are both view groups, which we mentioned before are called parent views. Then the children views are positioned based on their parent. Let's look at an example of one parent. A parent may tell their child to sit or stand in a specific place and not to move. Let's ignore the possibility that the child might want to get up and run around, because that's just an edge case. On a device, this means that a parent has control over where to position its children. For example, one child text view can be at the top of the screen, and then a second child image view can be below that. Or if the parent wishes, they can rearrange the children in a different way. The child image view can be on the left, and then the child text view can be on the right. We're going to talk about view groups in more detail in this lesson, but to make sure that you've understood what we've covered so far, please answer these questions. For the screenshot on this device, can you tell me how many views there are? Number 2, for the mountain image, is it a child or a parent of the red view group? Number 3, is the red view group a child or a parent of the hiking text view? Number 4, which of these views are siblings of each other? And you can just list them here. Okay, so how many views are there in this screenshot? Well, we have 2 text views and 1 image view, so that makes 3 views. But then also remember that a view group is also a view, so that's actually 4 total views. So we write that in here. Sorry, I know that was kind of a trick question, but now you'll remember it for next time. Next, the mountain image is a child or parent of the red view group. If I draw in the faces, hopefully you remember that the image view is a child of the red view group. So I circle this one in. Number 3, the red view group is the child or parent of the hiking text view. If I draw in more faces, then we see that the red view group is the parent of Tommy text view. So we circle this in. Number 4, which views are siblings of each other? Well, the 3 of these views are siblings of each other. So we have the mountain image view and the 2 text views. Okay, great. So now we know about how view groups can contain views. Each view group has specific rules on how it will position the children inside of it. First, let's look at LinearLayout. This view group can arrange children in a vertical column, like this. Notice how we're not limited to just 1 text view and 1 image view. We can put as many of them as we want in here, as well as other types of views. So this is Tommy, and this is his brother Timmy, and this is Ivy and her twin sister Irene. Or the linear layout can arrange its children views in a horizontal row, like this. Hey, if you want to say no boys allowed, that's totally fine with me. This is Ivy, Irene, and Isabella. Okay, and that's it for a linear layout. Pretty straightforward, right? You can arrange children in a vertical column or in a horizontal row. And then we have DAD, the relative layout. A relative layout, again, has its own rules for how to position its children within it. For example, it can position children relative to the parent. So if this is the parent view group, we can have a child text view aligned to the bottom of the parent, and a child image view aligned to the top of the parent. This also works for aligning to the parent's left and right edge, as well as the center. The other useful capability of relative layout is that you can position children relative to other children views. So if this is the parent view group, then you can position an image view on the left edge of the parent, and then position a child text view to the right of that image, and then this child text view is positioned to the right of the image view, but also below this first text view. So you see how some of these children views are aligned relative to the parent or relative to each other. That was a really quick overview of linear layout versus relative layout. You can see how you might pick one over the other depending on the type of layout that you want for your app. Now let's look at the XML for how a view group contains other views. In this example, we'll start with a view group that contains two child text views. This is a little more code than we're used to, but I want you to make some observations about this code. As a hint, the parent code is in red and the child text view code is in blue. We've linked that code below so you can take a look at it, and then write down 3 observations here. Now here are some observations that you may have made. There's no right or wrong answer here. We just want to get you in the habit of identifying things that you do or don't know in some code. So you may have noticed that this starts with an opening angle bracket and then the name of the view. Ding, whoosh. And then there's a bunch of attributes, pew, 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 and then a closing angle bracket, boom. But there is no /. That may come later. You may recognize the values of width and height, which means the size of the view group will shrink to wrap the content inside of it. Then there's this new attribute that you haven't seen before, Android orientation vertical. You may make some connection with the way that these are vertically in a column. Then there are these 2 text view elements. From looking at the attribute text, it seems like guest list is here and Kunal is here. Looks like it's a party for one. Then we have this funny group of symbols down here. You may or may not recognize it from earlier, but this is an open angle bracket, / linear layout, and then close angle bracket. This is the closing tag, and this is the opening tag. You get brownie points if you remembered that from the beginning of the lesson. Cool, so let's look at more code examples and dig into this more. Okay, so we saw how this linear layout contains 2 children text views inside it. By the way, these background colors are just a teaching tool to help you understand that these 2 children text views are inside this parent. The red and blue colors actually won't show up on the device unless you specifically set them as background colors on these views. To show you what I mean, let's go to the XML visualizer. If we drop in the code to the XML visualizer, this is what it looks like on the device. So first we have a linear layout view group, and this is transparent because there's no background color set on it. The first child is a text view that says guest list, so that shows up at the top here. The second child is a text view that says Kunal, and that shows up below the first text view. Now if I copy this text view and paste it below this one, what do you think will happen? Yep, we have another Kunal that shows up right below the first one. Okay, so the pattern seems to be if we add more text views here, then they'll just show up one after the other in this list. Now let's look at the code more closely. It starts with an opening angle bracket and then the view name, which is linear layout. Then it lists a bunch of attributes, and then there's a closing angle bracket. Notice that there's no / because this is just the opening tag of the linear layout. The closing tag is all the way down here because we want to insert children elements in between the opening and the closing tag. But for example, for this text view, since there are no children within that, then we can just use a self-closing tag for it. Same for this text view here and this text view here. So when we say a view group contains children views, then we need to insert them in between the opening and closing tags. Now the other thing you may have noticed is this attribute called Android orientation equals vertical. We haven't seen this before, so let's look at the Android documentation like I showed you earlier. I open up a new browser window and then I type in Android orientation. The first result is about a linear layout, and it's on the developer.android.com site, so let's click on it. Just like the text view documentation was a little overwhelming, we can ignore most of this text. We just need to verify that this indeed is the page for linear layout, and then we scroll down and look at the XML attributes. Now we're looking for the attribute that is called Android orientation. And here it is, so let's click on it to look at more details. The description says that this attribute determines whether the layout should be a column or a row. The value of this attribute should be horizontal for a row, or the value should be vertical for a column. And then it lists those two values here. Cool, so our code currently says that the Android orientation is vertical, so that explains why the views are showing up as a column. Now to satisfy our curiosity, we should also try the other value. Let's set the orientation to be horizontal and see what happens. I'm going to go into the code and erase the vertical value. I'm going to type horizontal, and look, now the views are in a horizontal row. I don't know about you, but I don't really like to read my guest list horizontally, but there are still many other useful cases where you would want a horizontal linear layout. For example, if you're creating a list item, you might want an image on the left-hand side and then a description on the right-hand side. I'm going to let you try this out on your own in a second, but first I want to point out this additional line of code. This is the XML namespace declaration. We use this namespace in order to specify that all of these attributes here belong to Android. That's why they all start with Android:. This is essentially shorthand for this specific URL that's unique to Android. You can actually create your own custom attributes. So to prevent name conflicts, where two attributes are named the same thing but actually have different behaviors, we always add this prefix here, Android:, to signify that these are Android attributes. So basically, always remember to add this XML namespace declaration in the opening tag of the root view of your XML file. Now it's your turn. We want you to be able to experiment with the linear layout code now. Try to add more text views so there's more items in this column. Who would you put on an exclusive guest list for your party? Also try changing the linear layout orientation attribute. Remember that it can be set to vertical or horizontal. If you open up the link to the XML visualizer that we provided you in the instructor notes, then this is what it would look like. We have a linear layout with a text view that says guest list and another text view that says Kunal. The first task was to add more text views to create the guest list. So let's copy and paste this XML element. Cool, let's add some other people besides Kunal. Let's add Kaguri and also Lila. Awesome. So now Kaguri and Lila show up under Kunal's name. We can also change any of the existing text views. We could change this to be the VIP list. The second task was to change the orientation attribute to be horizontal. This immediately changes all the text views to appear side by side instead of one on top of each other. So we've been making a guest list so far for the party.
Wait, this is the guest list for the birthday party, right, Catherine?
Yeah.
I really hope I'm on this list.
Well, we'll have to see about that.
Wow, I feel really small about that.
Well, speaking about small, let's talk about the size of views on a screen.
Oh, we've used the fixed width and height, which is the DP, right?
Yeah, for width and height.
Right.
And we could also set wrap content
Right,
for
which
the
is
view.
a strange way of saying that the view is going to wrap itself around the content. So the content grows large, the view grows large. The content grows small, the view grows small.
Yeah, and there's actually a third one, which is called match parent.
Seems a little strange. That sounds like a dating website for single parents.
Not quite. Match parent means that the view will be as wide or as tall as the parent.
Oh, so that makes sense. I am a view. I have a parent. And my width and height is going to be the same as my parent. Okay.
Exactly. So to summarize, the different values that you can set for a size of a view is with fixed DP for width and height.
Correct. You can also do wrap content. And the next one we're going to try out is match parent.
Here are some examples of how setting different widths on the child views in a linear layout can affect the final user interface. In this example, we set each child view to have a fixed width of 200 dp. If the content inside each view is greater than 200 dp, then you run the risk of cutting some content off like this. In this example, we set each child view to have a width of wrap content. Now all the content is shown, but the width of each view really varies based on what's inside each view. In this example, we set the width of each child view to be match parent. Now you see that the width of each child is as wide as the parent view group, regardless of the content inside of it. Now those same values can also be applied for the height of each view. In this example, we set the height of this child text view to be 200 dp. If the content inside it is taller than that, then you run the risk of cutting off some of the content. In this example, we set the height of the child text view to be wrap content. That way, all the content will be displayed on screen and nothing will be cut off because the size of the text view is dependent on the content inside of it. And in this example, we set the height of the child text view to be match parent. That way, the child view is as tall as the parent itself, regardless of the content inside it. Let's open the XML visualizer now and try to be more like our parents. In the code, we're providing you a link to the XML visualizer with some starter code in the instructor notes below. In this case, the linear layout is the root view of this layout because it's the first and outermost view. If we set match parent for the width and height of this root view, and we set this as the main layout of our app, then this linear layout will be as tall and wide as the device screen. I can show you by setting the background of this linear layout to be a non-transparent color. If I set a gray background color on this linear layout, then you can see how the gray extends the full width and height of the device. Now what happens if I try to change the width or height of these text views to be match parent? To make it clearer where the bounds of each view are, I'm going to set a background color on each of the views. Now I'm going to change the height of this text view to be match parent. By the way, you spell it match_parent. And now you see that this text view takes up the full height of the parent. Unfortunately, it pushes everything else off the screen, so we don't really want that, so let's change it back to wrap content. Okay, so let's change the width now to be match parent and see what it does. Now the width of the text view is as wide as the parent, which in turn is as wide as the device screen. If I change the other text views to also be match parent, you can see that it also starts to take up the full width of the parent. I also want to point out one more thing. Every time you see an attribute that starts with layout underscore, like layout height or layout width, these are actually view group layout parameters. These are used by the parent view group to determine the size and the position of these views. Meanwhile, the other attributes like background, text size, and text are handled by the text view in terms of styling its own view. But these view group layout parameters are handled by the parent. Now it's your turn to try different width and height values. For the link to the XML visualizer with some starter code, see the instructor notes below. Try to change the width and height values of each text view. You can set a fixed DP value, wrap content, or match parent. Remember that for each view, the width and height values don't have to match. When you're done, check this box to continue. In the previous video, I showed you what happens when you set match parent for the width of each of these child views. The text view ends up extending across the full width of the parent. There's no right or wrong solutions for how you experimented with the code. Here's another thing you could have tried. If you set the linear layout to have an orientation of horizontal, then the views will be displayed in a horizontal row. If you set match parent for the width of the VIP list, then it unfortunately knocks off the other views off the screen. If you set match parent for the height of the text view, then you see that the VIP list text view is now the full height of the parent linear layout. The same can be done for the other children views. Or you can set a fixed height. In the previous video, we showed you what happens when you set match parent for the width of each of these child text views. The text view extends to the full width of the parent linear layout. If you set a fixed height on the text view, like 300 dp, then this is what it will look like on the device. There's no right or wrong answers for what you tried out. Let's review. So far we learned that a linear layout can have an orientation that's horizontal or vertical. But now let's think about whether these views are taking full advantage of the screen real estate. When I say real estate, I mean the available space on the screen. For our Nexus 6 phone, say we have a vertical linear layout that has 3 child text views inside: Tom, Tim, and Todd. When we hold the device in portrait mode like this in our hand, then all the text views are grouped in the top left corner of the screen. There's all this blank space left unused. Similarly, if we rotate the device to landscape mode, then the text views are in the top left corner and there's all this blank space left. It's even more noticeable on a tablet device where the screen is a lot bigger. We're only using a small amount of the screen real estate and the rest of it is blank. We're going to learn about how we can more equally spread out these views across the screen to take up more of the available room. This applies to other views as well. You can have bigger images across the screen for a better experience instead of having them really tiny in the top left corner. Same with buttons. You could have bigger buttons so that it's easier to tap on those buttons. For the purposes of our example, we're going to stick with text views. So let's go to the XML visualizer to figure out how we can spread out these views. So here's the code for Tom, Tim, and Todd. I have 3 text views within a vertical linear layout, and this is what they look like on the device. Now I want to show you how you can spread out these 3 text views so that Tom is up here, Tim is here, and Todd is down here. Clearly, setting height for wrap content is not doing the job. The other thing we learned is to set a fixed dp value for the height. So I'm going to set the height to be, for example, 200 dp. Cool, so that left a lot more space for Tom. If I do the same for the other text views, then they also spread out more evenly across the screen. But this solution will only work for this size of a device. If I have a tablet like I showed you earlier, then these views are still going to be grouped in somewhat of the top left corner. The other option for setting height is match parent, which we learned earlier. When you set match parent for the Tom text view, it takes the height of the whole parent, which is the whole screen. That pushes the other text views off the screen so you can't even see them. So let's not do that. Well, now we're out of ideas because we tried wrap content for the height, we tried a fixed dp value, and we tried match parent, and none of those give us the right spacing across all different devices. Let's Google search for a potential solution to this problem. We're using a linear layout view group and we want to equally space out the children views, so let's search for that. Okay, so there's a bunch of search results, but let's click on this first one. This is a link to the Stack Overflow site. It's a Q&A site where you can post questions and get answers from other Android developers. I use it all the time when I'm stuck and I need help on a problem. Oftentimes, other people have already asked a question that I'm having. So this question here is about how to evenly distribute buttons across the width of a linear layout. This is similar to what we're looking for, except instead of buttons, we're working with text views. And instead of the width of the linear layout, we're trying to spread it across the height of the linear layout. We can read through the question, or we can skim it. Usually I just skim for the answer. So this solution received 88 votes and has a green check mark on it. It talks about how you can set layout width to 0 dp and set the layout weight for each of the buttons to be 1. And that splits the available width equally across the buttons. You may not fully understand the answer at this point, but that's okay. One key phrase that we saw is this linear layout weight. We haven't encountered this before, but it sounds important to the answer. So let's copy it and Google search for more information about layout weight. So let's search for linear layout weight. The first result is an article for linear layout, and it's on the developer.android.com site, so let's click on it. So this is an article about the linear layout. We already learned the stuff at the top about the Android orientation attribute. But then there's new information about something called layout weight. There's also an example at the bottom of the screen here with some code and a screenshot. I could summarize all of this for you, but first I want to give you a chance to read this documentation and try to figure it out on your own. This is going to be a lot more similar to how you're going to solve problems after this course is over. You'll look for some information online and try to figure out how that can be used to solve your problem. Okay, so this is the layout that we have now on the device, and this is what we want to achieve. The 3 text views are spread out evenly across the height of the device. To solve this problem, I want you to read the linear layout article that we linked below. It's perfectly normal for you to not understand everything that's in the article. Oftentimes, you just want to have some vague understanding of how the concepts in the article may be able to help you in your work. Then I want you to provide some ideas on how we can build this desired layout in XML. You don't need to provide the full XML layout code because we're going to walk through that together in the next video. But here you could write a couple sentences or bullet points on how the information in the article could relate to our problem. So I asked you to try your best at reading this article on linear layout. knowing that you probably would run into concepts and terms that you may not understand, but that's totally okay. Hopefully each time you read the documentation, you understand a little more each time. We're going to spend the next few videos learning about layout weight in more detail. But here's one thing that could be useful to our problem at hand. This section is called Equally Weighted Children, and it talks about how we can create a linear layout where each child is given an equal amount of space, whether it's a vertical layout or a horizontal linear layout. For a vertical linear layout, we would set the layout height attribute of each child view to be 0 dp. Then we would need to set the layout weight attribute of each view to be 1. I'll show you what this looks like in the next video. In the last quiz, we were trying to figure out how to give the Tom, Tim, and Todd text views a little more personal space by spacing them out equally vertically across the height of the device. We tried setting a fixed dp value, but that wouldn't work if we switched to a taller device like a tablet. Then we tried match parent, but then that made the Tom text view really big, but then it knocked the other two text views off the screen. So then we started researching about linear layout weights. In the documentation, it said that for a vertical linear layout, if we want to equally space out the children, we need to set the height to be 0 dp and a weight value of 1 for each of the children. Assigning a weight value to a child view is like assigning an importance value to it. The higher the weight value, the more space it may get if there's available space in the parent left. So for example, for this vertical linear layout, it fills down vertically this way. It turns out that this linear layout has a lot of extra space, and that will be distributed to the children that have weight values. If a child has a very high weight value, then more of this available height will be given to that child. If a child has a very tiny weight value, then less of this available height will be given to that child. I can show you what it looks like. I'm going to set the height of this child to be 0 dp and then give it a weight of 1. The linear layout first lays out Tim and Todd text views because they have a fixed height based on the content inside of it. And then there's this Tom text view that has an initial height of 0 dp but a weight of 1. None of the other children have a weight value because the default weight value is 0 if it's not specified. So this is the only child with a weight value, so the parent gives all of the remaining height of the screen to this Tom text view, and that's why you see the Tom text view is like so giant. Let me try assigning weight values to the other children now. So now each child has a height of 0 dp and a weight of 1. This is the process that the linear layout would go through. It would try to figure out the height of each of these views. The height of these views starts at 0 dp, so that means the available remaining height in the parent is basically the whole height of the screen. It divides the whole height of the screen by the weight sum, which is 3, and then it gives 1/3 of that available height to Tom text view, 1/3 of the height to the Tim text view, and 1/3 to the Todd text view. These will still be evenly spaced across the height of a device, even on larger screen devices as well, because of this weight value. If I change the weight value to be something higher, then the parent will give more available height to the Tim text view. I can change it to an even higher weight value, and you can see how it continues to get more available height. In this case, the Tim text view has a weight of 8, Tom has a weight of 1, and Todd has a weight of 1. So the weight sum total is 8, 9, 10. So the parent divides the available height divided by 10, and 1/10 goes to Tom, 8/10 goes to Tim, and 1/10 goes to Todd. So for a vertical linear layout, say we have 3 child text views. We set the initial height to be 0 dp, so they're all stacked up at the top of the screen with 0 height. That means the parent has all this extra height available. If I set a weight of 1 on each child text view, then the available parent height will be distributed equally across each of the children. The same would work for a horizontal linear layout. Say we have 3 child text views. We start with a width of 0 dp. That means the parent has all this extra width available. If I assign a weight value of 1 to each child view, then we're going to take the available width left in the parent and distribute it equally among each child. And again, it doesn't have to have a weight of 1. It could be 2, 3, or any other value, or it could even have a weight of 0. If a view has a weight of 0, that means that it won't change depending on the available space left in the parent. It will basically stay the width and height that you give it. One thing I want to point out is when to set the height to be 0 or the width to be 0. If you have a vertical linear layout, you're filling the linear layout vertically this way. So you don't know what the height should be, so you set the height to be initially 0 dp and you give it a weight value. Similarly, for horizontal linear layout, you're filling it horizontally, so you don't know the width yet of the child views, so you set the width to be 0 dp and give it a weight value. Essentially, you can think of assigning a weight value to a view as being able to stretch it out depending on how big the parent view is. This is good for filling in the available space within a small device or a large device. Here are a couple examples in real life where layout weights are really useful. This is the Google Hangouts app. You can use it to chat with your friends or send sleepy penguins to them. In this bottom part of the screen here is where you send your message. Let's look at this layout down here a little more closely. It's a horizontal linear layout because it's laid out in a horizontal row. It's made up of an image view, an edit text field where you can enter text, and then another image view. Now the height of each of these views is actually wrap content because it wraps to the content inside of it. The width of these two image views is wrap content because it's only as wide as the content inside of it. We give it a weight of 0 because we don't want it to be any bigger than this, even if there's lots of space in the parent left over. Setting the weight of 0 ensures that it will only be wrap content for width and height, and it won't change. We want it to stretch so that it's a little bit bigger on larger screen devices, and we want it to shrink if it's on smaller screen devices. So we set the width to be 0 dp and the weight to be 1. That means that the parent linear layout will try to lay out this image first and then this image, and then any remaining width in the device will be given to this view. Here's an example in the Maps app. This is a detail page for a location. There are 3 buttons here: Call, Save, and Website. Let's look at them more closely. You can actually build these as text views with icons attached to them, and you can see the instructor notes for more details, but that's really a tangent point. For this exercise, let's assume that these are text views. The height of each text view is going to be wrap content because it wraps to the height of the content inside of it. Now the width is a little bit trickier. We want each of these text views to be spread out equally across the width of the screen, depending on whether it's a small device or a really large device. We don't want all 3 text views to be grouped into the left-hand side of the screen. So to space children out equally, we give them equal weights. We set a width of 0 and a weight of 1 for each of them. That way the available width in the parent will be spread out equally across the 3 children. And the last example is an email app. This is the compose screen in Gmail where you can write a new message. It's a vertical linear layout because the items are in a column, and it's made up of 4 different edit text fields. Now the width of each child is match parent because we want it to stretch across the whole width of the device. For height, we set these 3 edit text fields to be wrap content, so it wraps the text inside of them. We set the weights to be 0 because we don't want them to increase in size even if there's available height in the parent. But for this last edit text field, this is where you write your message, and we want to give the user lots of space to write a really long letter to grandma. So we set the height to be 0 dp and we give it a weight of 1. So if the parent has any available height left, it will be given to this child edit text field. On a larger screen device, the compose email field will be a little bit taller, and on a smaller device it will be a little bit smaller. Now it's your turn to practice. We want you to go ahead and build this layout in the XML visualizer. You can start with the XML that we've provided below. Here are a couple tips. When you try to tackle something like this, try to first determine the width of each view, and then go ahead and try to determine the height of each view. Also, make sure that the image takes up any remaining height in the parent linear layout. So on a smaller screen device, it will take up less height. On a larger screen device, it will take up more height. Okay, go for it. Check this box when you're done. So to build out this layout, I like to first think about it conceptually to make sure I have an idea of what I'm going to do before I start coding. First, we notice that it's a vertical linear layout because the items are in a vertical column. We have 3 children views. We have an image view, a text view, and a text view. The first hint that I gave you was to first determine the width of each view. Since the whole layout takes up the full width and height of the device, this vertical linear layout has a width and height of match parent. Then for the image view, we want it to also be as wide as the parent, which in turn is as wide as the device. So we set that to be match parent. Same for the 2 text views. We want them to match the full width of the device, so it's match parent. Then we work on the height of each view. These two text views are easy because they wrap to the content inside of them. So we set wrap content for the height of each text view. We also set the weight values to be 0 because we don't want these values to change even if there's available space in the parent. Now the image view was the hardest part. We want the height of the image to grow or shrink depending on the available space in the parent, which depends on the available screen size of the device. We use weights to accomplish this. We set the height of the image view to start at 0 dp, but we give it a weight of 1. Since none of the other children have weight values, then any available space in the parent will be given to this image view. And the reason we set the height to be 0 dp is because it's a vertical linear layout, so it fills itself vertically, and we don't know the height yet until the weight value determines it. We gave you this link in the instructor notes, and it had some code already in it. The positioning of the views is incorrect though, so let's fix that. Let's start with the text views first because those are easy. You can see that these text views don't stretch across the whole width of the device, so we need to change that. The width should be match parent. Ah, that's better. So now the greenish bluish background goes across the whole width of the device. Same for the bonfire at the beach text view. Cool, and the height is wrap content, which is correct. Now we have all this extra vertical space in the vertical linear layout. Oh, by the way, the width and height of the linear layout is set to be match parent so that the layout will eventually extend the whole height and width of the screen. So to use this extra height in the parent, we want to give it to a child that has a weight value. So let's change the image view so that it has a weight value. First we can set the width to be match parent so that it also extends across the width of the device. Then we set the height to be 0 dp and the weight to be 1. And that's the desired screenshot. Good job. Note that if I change the weight values to be a really high number like 7 or 10, it doesn't really change the device preview. That's because this is the only child with a weight, so it doesn't matter if it's a really high weight or really low weight. All the extra height in the parent will be given to this child. So let's just change this to be 1. Okay, good job. So far we've learned that a linear layout can have a vertical orientation or horizontal orientation. We also learned that individual views can have weight values to fill up the extra space in the parent. Now we're going to spend some time learning more about the relative layout view group. This will help you build even more flexible layouts. Do you remember Ray, the relative layout? He's the dad, and he's represented by this view group here. He helps the children views be positioned within this container. With a relative layout, you can position children relative to the parent, such as the top of the parent or the bottom of the parent. The other option is to position children views relative to other children, like this. Let's focus first on the case where views can be positioned relative to the parent. For this example, this parent relative layout is set to have width of match parent and height of match parent, so it's as big as the device. The children inside the relative layout can be positioned relative to the parent's left, top, right, or bottom edges. This is the code for it. On the child view XML elements, for example for the image view or text view, you would add these attributes. The attribute name follows this format: Android:layout_align parent top. This attribute determines whether the child view is aligned to the parent's top edge or not, so the possible values are true or false. If it's true, then the view should be aligned to the parent's top edge. If it's false, then it shouldn't be aligned. There are attributes for all the other edges as well. For example, align parent bottom for aligning to the parent's bottom edge. There's align parent left for aligning to the parent's left edge, and then there's align parent right for aligning to the parent's right edge. You can mix and match and use multiple of these attributes at a time. Take this image view as an example. We would set the attribute align parent top to be true because it's aligned to the parent's top edge. It's also aligned to the parent's left and right edges, so we set left to be true and right to be true as well. It's not aligned to the parent's bottom edge, so we set that to be false. And for this text view down here, it's aligned to the parent's bottom edge, right edge, and left edge. So align parent bottom would be true, align parent left would be true, align parent right would be true, but align parent top would be false. In addition to positioning a child at the top portion or the bottom portion of the screen, you can also do specific corners. If we want to position the birthday text view in the top left corner, we say align parent top to be true, and then align parent left to also be true. To position a view in the top right corner, we want to align it to the parent's top edge and right edges. So align parent top equals true and align parent right equals true. For the bottom left corner, we're aligned to the parent's left edge and bottom edge. So we say align parent bottom equals true and align parent left equals true. These values are false, and they're false by default, so you don't need to include them in the XML code. And then for the very last corner, it's aligned to the parent's right edge and bottom edge, so align parent bottom and align parent right are equal to true. The other two are false, so we can leave them out of the code. Believe it or not, there's even more attributes that you could set. You can also center the view horizontally. So you set Android layout underscore center horizontal to be true. And you can also add it to the existing attributes we learned before. So if this is aligned to the bottom and it's centered horizontally, it would look like this. The last one I'm going to show you is layout center vertical. If this is set to true, then it centers the view vertically within the parent. The reason why this text view is aligned to the left edge of the parent, even if we didn't set this value, is because all views that are added to the relative layout are positioned by default in the top left corner of the view group. All of these attributes are called view group layout parameters. Even though they're declared on the child XML elements, they're used by the parent view group to know how to position the children. Thus, they all start with layout underscore. This also follows the pattern of layout underscore width and layout underscore height, which you're already familiar with. Those two attributes are also view group layout parameters because they're used by the view group parent in order to position and size the children. And here's the XML for relative layout and its children. You can follow along in the link below. We have an opening relative layout tag and we have a closing tag at the bottom here, and all the children are in between. The width and height of the relative layout is set to be match parent. Since this is the layout for our whole app, it's going to take up the whole screen. There are 3 child text views inside the relative layout. The first one is a text view that says happy. The width and height are wrap content, and we have these additional attributes to help the relative layout know where to position this child text view. We tell it to align to the parent's right edge and to align to the parent's top edge, so that puts the happy text view in the top right corner of the screen. For the birthday text view, the width and height are also wrap content. Then we want to align to the parent's bottom and left edges. So the bottom and left edges leads to this corner down here. This last text view that says to you doesn't have any specific attributes specifying where it is relative to the parent. All we know is that the width and height should be wrap content. As I mentioned earlier, if you don't specify where a child view should go, by default the relative layout will add it to the top left corner of the screen. Alright, now it's time for a quiz. In the instructor notes below, I'm going to provide you with a link to this code. This is the XML for a relative layout. I want you to read through it, try to imagine what it would look like on the device. I know that you're fully capable of copying and pasting, so I don't want you to put it in the XML visualizer, because then that will do all the hard work for you. In this course, we also want you to be able to practice reading code. That means looking at some code and then figuring out what exactly it will translate to in your app. Experienced developers become quite good at this because then they don't need to actually run it on the device to know what it would look like. They can just modify the code here and just keep working on it, knowing in their head what it would look like. For you, since you're starting off, I want you to carefully read this as best as you can, and then you can draw it out on a scratch piece of paper if that helps you. Then tell me if the device would look something like this or like this. Go ahead and click on the option that you think best represents what would happen on the device for the XML that we gave you. The layout starts with an opening tag for a relative layout. The closing tag is all the way down here, and the children XML elements are in the middle. The width and height of the relative layout is set to be match parent. Since this is the only layout for our app, this is going to take up the full width and height of the device. Then we have our first text view that says, I'm in this corner. It's aligned to the parent's bottom and left edges. That puts it in the bottom left corner of the screen. Going back to the quiz screen, the text view, I'm in this corner, is in the bottom left edge of the screen. The next text view says, no, up here. This is aligned to the parent's top and left edges. That puts it in the top left corner of the screen. And indeed we see that no, up here is in the top left corner of the screen. The third text view says, wait, I'm here. This is aligned to the parent's bottom and right edges. This puts it in the bottom right corner of the parent. And we confirm that it's in the bottom right corner. For option B to be fully correct, the last text view should be located in the top right corner of the screen. And it should say, actually, I'm here. And indeed, the last text view says, actually, I'm here. And it's aligned to the parent's top and right edges. When positioning children relative to other sibling views, you can add constraints on their position. For example, one text view must be above another text view, or one image view must be to the left of another text view. All these constraints remind me of making a seating chart for a dinner party. We do have our birthday party celebration coming up, so let's look at the seating chart for that. We invited all these people over for dinner, but there are constraints on where people want to sit. Some people must sit next to their best friend. Other people have what you might call frenemies, so they might not want to sit next to certain people. So taking into account all of that, I came up with this proposed layout. Kunal, Ben, and Kaguri are up here. Natalie, Lila, and me are down here, and Amy, Emoju, and Jenny are in this corner. So could we build this seating arrangement in XML using text views and a relative layout? We know how to position views in corners. So the Lila text view would be aligned to the parent's left edge and bottom edge. The Jenny text view would be aligned to the parent's right edge and bottom edge. For Ben, we would align him to the top edge of the parent. By the way, we're assuming that the parent is the full width and height of the screen. So we've set match parent for width and height. So back to Ben. He's aligned to the top of the parent. We also want to center him horizontally. Informally, you might call these three views the anchor views, because everyone else is positioned relative to these people, and these people won't move regardless of where everyone else is sitting. So let's add another person. We have Kunal here, who's located to the left of Ben. But how do we express that in XML? Well, there's no specific attribute that says that a view should be to the left of a view named Ben. All the Android attribute names are general, so that it works for any use case that you would want. We want to position Kunal to the left of Ben, but we don't know of any existing attribute names that can do that. Luckily though, RelativeLayout has an attribute that says Android : layout to left of. This means that the Kunal text view should be to the left of some view. And the way we specify some view is to use view IDs. We can assign view ID names to any view. They don't have to be specifically just for RelativeLayout. They could be located within a RelativeLayout or a LinearLayout or any other view group. So on the Ben text view, we can add this attribute Android ID. The value of it is the ID name. The format starts with an @ symbol. @ refers to a resource in our Android app. We've also seen this @ symbol for referring to images in our app, for example, @drawable. Then we specify the resource type. In this case, the resource type is an ID. We also add the plus symbol, because this is the first time we're declaring this ID. Then we have a slash, and then we have the name of the view. This is the name that we chose for the Ben text view. We call it Ben_text_view. The basic requirements are that the name can't have any spaces, that's why we use underscore symbols here. It needs to start with a letter, and it can't contain any of the weird punctuation symbols. Numbers are fine though. So in this case, we give Ben the ID of Ben_text_view. That way we can refer to it later. So on the Kunal text view, we can add the attribute layout to left of, and we can say it's to the left of the Ben text view. We refer to the ID for the Ben text view using @ID. We don't need to use the plus symbol because we've already defined that ID. This is the second time we're using the ID. When you come up with view ID names, make sure that they're all unique names. Usually picking something related to the content inside of it is helpful. Okay, cool. So that's how you position Kunal to the left of Ben. Now say, for example, we want to position Emoju above Jenny. Since we're going to need to refer to Jenny, we should create an ID for Jenny. On the Jenny text view, we specified this attribute and give it this value. The ID name is Jenny_text_view. On the Emoju text view, we add this attribute. This says that Emoju should be positioned above the Jenny text view. And this is the ID that we created up here. Let's look at the XML layout. We have a relative layout where the width and height are match parent. Then we have the Lila text view. It's aligned to the parent's bottom left corner. And that's what we see down here. Then we have the Jenny text view. It's aligned to the parent's bottom right corner. So that's over here. Then we have the Ben text view, and it's aligned to the top edge of the parent. It's also centered horizontally. These are the anchor views, and now we can position the other views around them. Notice that for each of the views, I already went ahead and added an ID. So this is the Ben text view ID. Then we can position the Kunal text view to the left of Ben. I align Kunal to the top of the parent and to the left of the Ben text view. I use the view ID for Ben right here. Then we position the emoji text view above Jenny. Emoji is aligned to the right edge of the parent and above the Jenny text view. Okay, cool. So there's more friends to position correctly in this layout. In the instructor notes below, we've provided you a link to the XML visualizer with some initial code already in there. Go ahead and modify the XML so that we can achieve this desired layout for everyone. Some of the views are already positioned incorrectly, so you'll need to fix those. By the way, we just introduced a ton of new attributes, but don't feel like you have to memorize all of them. You can always look them up at any time. You can just search for relative layout params. If you click on this first link, you go to the documentation for this. So these are all the XML attributes that you can put on a child view within a relative layout, so that the relative layout knows how to lay it out. Here are some that you're already familiar with: layout above, align parent bottom, align parent right, and so on. Note that for teaching purposes, the XML visualizer may not support all of these attributes. However, when you're developing an app in Android Studio, you should be able to use all of these. Okay, we gave you a link to the XML visualizer with this initial layout. From the device preview, we can see that Natalie, Kaguri, and Amy are positioned incorrectly. First, let's try to position Kaguri in the right place. She should be located to the right of Ben and aligned to the top of the parent. So I'm going to search the XML for the Kaguri text view. Here it is. Currently, it's aligned to the parent top, which is correct. But this is incorrect. We don't want to align her to the parent's right edge. Instead, we want to position her to the right of the Ben text view. So now she's located to the right of Ben. Notice that I use @id/Ben_text_view. There's no plus symbol because the Ben text view ID was already created up here. Next, let's position Natalie. She should be located above Lila and along the left edge of the parent. Here's the Natalie text view. It's located by default on the top left corner of the parent. Let's move her so that she's located above the Lila text view. And the reason why I use this name is because it was defined as Lila's view ID name up here. Okay, great. So Kunal, Ben, and Kaguri are positioned correctly now. And so are Natalie, Lila, and me. Next, we just need to move Amy from here over to here so that she's above the emoji text view. Here's the Amy text view. Currently, she's aligned to the parent bottom, but instead we want to align her to the right edge of the parent. So let's change that. Then we want to position her above the emoji text view. The reason why we know to use this ID is because it was defined as the ID for the emoji text view. Cool, and now it's in the right place. Now let's look at a more realistic use case for a relative layout. For example, this is a good view group to use when you're building a list item, like this. We've provided a link below with some XML for you to get started with. Go ahead and modify it so that you can build something like this. As a hint, first try switching from a linear layout to a relative layout. This is the original XML that we provided you. It was a vertical linear layout, and the items were appearing in a vertical column. According to the image in the quiz, we want the item to look more like a list item using a relative layout. Here's the solution. We've changed the layout so that the photo is on the left and the 3 text views are on the right-hand side. In order to build this layout, I changed the root view to be a relative layout instead of a linear layout. Since this is the opening tag, I also had to update the closing tag at the bottom. Between the opening and closing tags, we have 4 children views. I also removed the vertical orientation attribute because that belonged to the linear layout. There's no orientation attribute needed for the relative layout. The photo was already positioned correctly. The first child of a relative layout is always positioned by default in the top left corner. And that's what we want for our list item, so this stays the same. Next, we have the text view that says Pebble Beach. We want to position this text view to the right of the image view, so we need to add the attribute layout_to right of, and then reference the image view. In order to reference the image view, we had to add an ID attribute to the image view. I just called it photo, but you could call it something else if you wanted. That correctly positioned the image and the first text view. The next text view is for showing the text California. The California text view has to be positioned to the right of the photo and must be below the Pebble Beach text view. So first we add the attribute layout_to right of and reference the photo. Then we add another attribute, layout below, and then we reference the first text view. That required also adding an ID for this first text view. We just called it name. Cool, so that positioned the image view and the two text views. Lastly, we have the text view that shows the distance, 10 miles away. It's positioned to the right of the image and below the California text view. Thus, we had to add the attribute layout to right of and reference the photo. And we also had to add an attribute for layout below and then reference the location text view. This involved adding the ID for the location text view as well. I also added an ID for the distance text view. Even though we're not referencing it anywhere, it doesn't hurt to add an ID to a view. In the case that you do need to refer to it later, it's already there. Good job so far. You're well on your way to building really great layouts. However, I do see a problem with almost all of the layouts that we've built so far. The views are right up against the edge of the view group or up against the device. For all of the layouts that we've built in this lesson so far, we could add a little more visual polish to them so that they're more beautiful by adding a little bit more white space. We'll do this using the concepts of padding and margin, which we'll cover in this video. For example, we could add a little more white space here, here, or even at the top so that the views aren't crowded up against the edge of the parent and up against the edge of the device. It's really a design decision though, because sometimes you do want it to go edge to edge, like for the full bleed image effect that I was talking about earlier. But in any case, you can use white space to add a little more breathing room so that the content is a little bit easier to read and scan. I'll show you the effect of adding padding or margin to a view. Let's start with a text view that says hello. If we add 8 dips of padding to the view, then it makes it bigger by 8 dips in every single direction here. If we add a layout margin of 8 dips to the text view, then this is what it would look like. In order to add a margin, you need to put it inside of ViewGroups. That's why I have it in this linear layout here. The linear layout is the one that takes the original text view and pushes it by 8 dips from the left and from the top, and also from the sides as well. So even though you declare padding or margin on the child text view, the padding gets handled by the text view itself, whereas the margin gets handled by the parent view group. If you run both of these on a real device, and you didn't have a background for the text view, then technically both would look the same. The text would start 8 dips over from the left and 8 dips below the top of the device. However, if you do have a background color for the text view, then the user would be able to see that the text view is this big, whereas on the other device, the text view would only be this big. Here's the code for displaying padding on a view. On the text view XML element, you would declare a new attribute that says Android:padding equals, and then 8 dips in quotation marks. You can choose whatever size you want for the padding, as long as it's a dip value. When we specify 8 dips of padding, it adds 8 dips to the left, top, bottom, and right edges of the text view. Instead of using the general Android padding attribute, you can also split it out to left, right, top, or bottom. Essentially, these 4 lines of code do the same thing as this one line. However, these fine-grained controls allow you to have different padding values for left or right, or top or bottom. You don't have to have an equal padding value for all 4 directions. The default value for padding is 0. So if you specify left, right, and top padding, but not bottom, then that will be 0 dips of bottom padding. To specify margin, you add an attribute again to the text view. The name of the attribute is Android:layout_margin. You can set it equal to, for example, 8 dips. This moves the child text view 8 dips away from the parent on all edges. If there was another child text view at the top here, then having a margin would push this text view 8 dips below that first text view. You can think of having a margin as having a little force field around this view. No other view can enter this 8 dip region around it. Or you can also split out layout margin into each of the 4 directions. Layout margin left, layout margin right, top, and bottom. If you don't specify any of these values, then it will default to 0. To remember that the view group is the one that positions these children based on margin, you can look at the attributes. They all start with layout_ for margin. That way you know that the view group is the one who's handling the positioning of these views. Padding and margin can apply to all views. Let's put the attributes we just learned about into practice. Here I have 3 text views in a linear layout. They're all squished up against the left edge of the screen, so I want to add a little more space. Let's start by trying to add some margin. Cool, now there's more space around this text view. I'll do the same for the other 2 text views. Interesting. So this is 16 dips up here, but this is actually 32 dips because it's getting 8 dips of bottom margin from the first text view and 8 dips of top margin from the second text view. If we want the spacing to be consistent, so it's always 16 dips in between each view, then we have to change the margin here. I can break it out into individual margin values. With this code, I have a left margin of 16 dips and a top margin of 16 dips. There's no bottom margin from this first text view, so this space in between is now correct at 16 dips. The same will go for the last text view. Cool, now all the vertical spacing is equal. Earlier when I said we're adding white spaces to the edges of these views, technically that space is transparent. You can see through it to what's behind it. In this case, we have a gray background on the view group. Now the layout would look the same on the device, whether we use margin or padding, because in this case we have no background color on the text view. Let's add it and see where the bounds of each view are. Okay, now there's a background color on this first text view. When we added the left and top margin, we see that the view group just pushes the text view over by 8 and down by 8. We can change this to padding, and now we see that the text view is larger and takes up that 8 dips of space on the left and top. So visually, things would look different on the device whether you have padding or margin if there is a background color on this text view. We can do the same for the other views so you see that as well. Adding padding and margin values isn't just restricted to these children views, you can also add it on the view group. If I add a padding value for the linear layout, then you can see that it shifts the views over by 16 dips in all directions. I mentioned that you could set any value for padding or margin. But how do you know which value to pick? Well, the material design guidelines recommend that you use increments of 8 dips. This is a little bit more advanced knowledge, but essentially we want our components to line up on the screen along this 8-dip square grid. Now the squares don't actually show up on the screen, but if you want to position text here, you might want to move it over like 2 squares to the left. 2 squares on this grid would equal 16 dips. On this email screen, all the icons are lined up to this line. They're positioned 16 dips over from the left edge of this screen. And all this text here is positioned 72 dips over from the left edge of this screen. So you can kind of imagine that the content is starting to follow certain lines here. Here's another way to visualize it. In this screenshot from the Google I/O app, we have the content lined up to this 16-dip line, as well as this 72-dip line. It's essentially 72 dips over from the left edge of the screen. And on this edge, the content stops 16 dips before the right edge of the screen. On the tablet, you have more screen real estate, so you can have a little more padding. You can be 24 dips over from the left edge of the screen, and so on for the other values. The reason we recommend these values is to make your content easier to read. For example, if this title was shifted over by a couple pixels and this subtext was shifted over to the right by a couple pixels, there would be a jagged edge here, and it would distract the user from actually reading your actual content. So by lining everything up, it makes your app easier to read and use. Here are a couple of real-life examples of using padding and margin. In this Google Calendar app screenshot, we see some text here that's shifted over by a little bit here. There's also a little bit of space between these calendar events. If we implement it using padding, then this background image would probably extend into that blank space. Instead, if we use margin, then it adds a little buffer zone around the view, so it's probably margin. Here's another screenshot of a detail page for a calendar event. There's a lot of text here, and there seems to be larger gaps than others. We can create those larger gaps by adding padding. To add this gap here, you could either add bottom padding to this text view, or you could add top padding to this view. Either way would work, or you could even implement it using layout margin. You really can't tell the difference between using layout margin or padding in this case because the background of the text views is transparent. Now it's your turn to practice with setting different padding and margin values. We've provided some initial code for you to get started using the link below. Once you're comfortable with padding and margin values, go ahead and try to build out this layout. By the way, this text is located 16 dips from the edges here, but it's only 8 dips in between the two text views. When you're done, check this box. To build the desired layout, the image actually goes edge to edge. So let's get rid of this padding that we have on the parent view. Cool, now the image goes edge to edge. Let's fix the text down here. We mentioned that we want 16 dips of padding all around the edges here. Okay, well I tried to add 16 dips of padding to this text view, but we originally wanted only 8 dips of padding here. So we should break this out into individual values and set the bottom padding to be 8 dips. Okay, now we have top, left, and right padding equal to 16 dips, but the bottom padding of this text view is 8 dips. Cool, so now this last text view should also get 16 dips of padding. But wait, now that increases the amount of space in between the two text views. Let's also add 16 dips of padding to this last text view. This makes the left and bottom and right spacing correct, but now there's too much space in between the two text views. So let's break this out into individual values. And we'll stop right there because we don't want any top padding on this view. The correct spacing is coming from the bottom padding of this text view above it. Cool, so that looks correct. The only thing that's missing now is the fact that we need to get rid of this white space here. We don't need a bottom margin on this image view, so let's delete it. Great work! We finished building this layout. Do you have an example of using a linear layout in your app?
Well, even here, this cluster of 3 cards is a horizontal linear layout where we just add child views, like 3 cards, and then we set layout width to 0 dip and layout weight to 1, and essentially it instructs a linear layout to take however much width it has at runtime and distribute it evenly based on the relative weights, distributed evenly between all the child views in that group. So that's one example. And another example would be over here that you have new and updated games, and the more button, which is a cluster header, it's also a simple horizontal linear layout. So when things are simple, you don't necessarily want to start writing custom layouts. Don't just use relative layout everywhere because it's more versatile than linear layout, for example. That's just overkill for simpler things.
So when a designer gives you a mock, how do you go about starting to build that app?
So hopefully at that point, like we talked, we have not just one mock, but rather at least 2 or 3 that show how the design scales between small screens and large screens. And then I want to identify building blocks. So if we talk about something like a card, which appears in a lot of places in the app, I wouldn't want necessarily to start like implementing a lot of variants of the same card based on if it needs to show a small image or a big image, or maybe show a 1-line title instead of 2-line titles. So I'm trying to identify these blocks and implement them as standalone classes, standalone layouts, and then start building on top of those. So you start from text view, image view, spinner, and whatnot to build smaller blocks. And then hopefully you are able to keep on taking those small blocks and build larger blocks while reusing the same basic set of blocks. And what's nice about it is even though you spend maybe a little bit more time up front, it becomes easier, especially if the design is consistent in how it applies its language to evolve the app and to add new features. If the design is consistent, then you keep on seeing the same blocks being used in different configurations again and again. And then that's where your initial investment starts paying off, where you don't treat implementation of a new screen as a brand new thing, but rather maybe 50, 60, 70, however much percent is already there. Maybe it needs a little bit tweaking with colors or maybe typography or whatnot. But hopefully, if the design is consistent, then the implementation is also easier to move forward if you already built for that. And it also becomes easier to apply a redesign just on the visual level. If you want to tweak colors, if you want to tweak typography, if you want to add maybe like we did in Lollipop, where you have these ripple effects when you press something. If you have a few pieces that you keep on reusing, your styles, your layouts, then you do that visual refresh in a fewer number of places, and then hopefully they get applied consistently everywhere. So for me, I want to place the focus at the beginning on getting the data right, especially for an app that is getting its data from external sources. And then do closer to the pixels, refine the pixels once you have the data, to do the grid, to do the typography, colors, animations, transitions, whatnot, however much time you have to spend on that. And I think it would be the same if you have something like a Twitter client. Like, you know, you can start by pixel perfecting your layouts with some fake data, and then you discover that like, you know nothing about fetching the data from Twitter, and it takes you the next 3 months just to fetch the data. Or just an example. So I prefer to start from the data. I think about this as an iceberg, where you see the pretty pixels as like maybe like 5–10% above the surface, and then there's a lot of work going below the surface, if you will, to support that.
You mentioned the tip of the iceberg is what people see. So what exactly is going on below the surface? How do you see the Google Play app?
So what happens below the surface is, first of all, to get the data from the network. So you have, like, you know, authenticate to the server and get the data, and then maybe to cache it locally, so that the next time you go, like, you know, you go from the stream into the details page and back into the stream, we should be using cached data, cached images, so that, like, you know, we don't put too much strain on the battery, and also the app already shows the information that it has. Then you have support for multiple accounts. Then you have maybe persisting a few bits here and there in the database. Then we have the billing flows, which is most of that work is done on the server to integrate with different payment methods. And then there's the work on the client as well. Another big part of the Play Store is downloading and installing apps. And games, we are, on the Play Store side, we are in charge of downloading, installing, updating apps, and so that's another big chunk of, once again, pretty much all of these have their surface bits, which are pixels on the screen, and then there's a lot of work going below the surface to bring that information for the right account and to put that on the screen.
It's clear that you've worked on many different iterations of Google Play app. How do you keep up to date with the latest news in Android?
There's a lot of information on Google Plus from very active Android developers who put out a lot of tutorials. And just from different blogs, sometimes I don't necessarily go and read deeply a certain series about, like, Recycler View or a view page or whatnot, or like how to configure the toolbar and action bar. I kind of try to put it like that I know that there's a lot of information in there, and then when I do need that deep level of information, then I go to those resources.
Well, thank you so much for your time, Kirill. I think our students will really enjoy hearing your perspective on what it's like to be an Android app engineer. Kunal, we missed you in the last interview with Kirill.
I know, I should have been there. I'll do the next one for sure.
Okay. But you know what?
What?
We finished lesson 1.
No.
Yeah, we're done.
You're telling me we're 1/3 of the way through the course?
Yeah.
Oh, that's great.
And you know what we should do now?
No.
We should recap.
We should.
So the first part of the lesson, we learned about how a screen is made up of different views.
Yeah, image view and text view.
And we learned how to style those views.
So if you want to change the color of a text, for instance. And then the final bit, what we did was took different views and put them together. So we call them view groups. We use linear layout, relative layout. We use margin and padding.
Yep.
And
So
that's
done
lesson
now.
1. All right.
I got a chill raspberry Fruit Lip